An algorithm, like long division, is supposed to crank out answers reliably and quickly, even if you don't understand the underlying mathematics. The notation is designed for speed, not comprehension. In general, the purpose of an algorithm is to avoid unnecessary thought. Sometimes that's a good thing. Sometimes it's not. For a task you do all the time, learning a time-saving method is a great idea. For a task you almost never do? First, a quick review of the vocabulary. This number is the divisor, this is the dividend, and this is the quotient. First, let's look at the way the long division algorithm is usually presented. Let's say you want to divide 4 into 528. In real life, you would probably just use a calculator to get the answer of 132. But let's look at the way a textbook might explain the problem. You know the drill. 4 goes into 5 one time. Subtract 4 from 5. Bring down the 2. Blah, blah, blah. This method is designed to let users perform long division quickly and reliably. The secret is that the person performing the long division only writes down the numbers that are absolutely needed to perform each step. This saves time and it avoids mistakes, but it also obscures the underlying mathematics. Here's what the same problem would look like if we were to write down all of the numbers in each step. For starters, we want to find the biggest round multiple of 4 that will go into 528. By a big round multiple, specifically we are talking about numbers that are multiples of the divisor and of the highest power of 10 we can manage. In this case, the biggest round multiple of 4 that will go into 528 is 400. That's 4 times 100. So we subtract that from 528 and we get 128. That 1 in our answer represents the 100 we multiplied 4 by. Now we want to drop down to the next lower power of 10. In this case, that would just be 10. The biggest multiple of 4 and 10 that will go into 128 is 120. Subtracting 120 from 128 gives us 8. 4 will go into 8 2 times, leaving 0. That's where we get the 2 from. So far, we've been talking a lot about powers of 10. When I mention that term, you probably think of numbers like 10 or 100 or 1,000 or 1,000,000. That's a perfectly valid way of looking at it, but powers of 10 also go the other direction. 0.1, 0.01, and so on. And by the way, if you notice there in the middle, 10 to the 0 power actually is 1. We've already talked about how long division is based on subtracting off multiples of successively smaller powers of 10. Long division problems with decimals still work exactly the same way, only now you keep going with powers of 10 smaller than 1, such as 1/10 or 100th or 1/1,000,000th. Take a look at this problem here. Can you see how we are still basically doing the same thing? When we get into decimals, we get into repeating decimals. Why do we get repeating decimals when we do certain division problems? Take a look at what happens when we divide 2 by 11. 11 times 0.1 is 1.1. So we subtract off 1.1 from 2, and up on the top we write the first 0.1. 2 minus 1.1 is 0.9. Now we have to drop to a lower power of 10, and we have 0.08 times 11 gives us 0.88. We subtract that off, and we get 0.02. Now you'll notice, other than the decimal place, we've just gotten back to where we started. We started with 2, now we have 0.02. So we subtract off 0.011, which is 0.001 times 11, and we get 0.009. See how we're getting the same numbers, just with the decimal point moved over? Well, this pattern will continue, and that's why this decimal will repeat. Of course, sometimes repeating decimals take a while to get around to repeating. Look what happens when we divide 1 by 7. If you want to know in advance whether or not a division problem will produce a repeating decimal, look at the divisor. If the denominator of the fraction has a prime factor other than 2 and 5, the decimal form will repeat. So 1 divided by 8, or 1 over 8, it means exactly the same thing, will not repeat, because 8 is simply 2 times 2 times 2. 1 divided by 25 will not repeat, because 25 is 5 times 5. 1 divided by 10 will not repeat, because 10 is 2 times 5. See, all of these are made of some combination of 2 and 5. 1/3 will repeat, because 3 does not have 2 and 5 as factors. 1 over 11 will repeat. 1 over 12 will repeat. Even though it has 2's in it, it has to have just 2's and 5's. There's a 3 in there. Anything other than a 2 and a 5 will cause the decimal to repeat.